Okay, welcome back everyone. In this video we're going to be talking about geometric optics, and in order to understand that, first we have to talk about what plane and spherical waves are. So first, a couple of quick vocab terms. So one very important term is called a wave front, and what this is basically a line or a surface that connects in phase parts of a wave. So let me show you what I mean by that. So here's an example of a wave that we could make in sort of a tub of water. You could take a wooden bar and sort of just oscillate it up and down, and you can see that you would get waves sort of moving from left to right. And these waves would have at the top a crest at Q and also at S and U and W, and at the bottom they would have a crest at points P and R and T and V, and then of course there would be troughs in between. So when we talk about a wave front, we connect all the points that are at the same phase. So we connect all the crests, and we also connect all the troughs. So that's basically what it means to have a wave front. So here's another view of this. This is a plane wave front, and here's another view, is that you have these wave fronts right here, and here's what it looks like if you have a spherical wave front, and this is when you have a source of waves that is a point. So for example, in astronomy, if you're kind of close to a star, then that would be a point source, and the waves would spread out in spheres. And by the time that the rays of light from the sun, for example, got to the Earth, the wave fronts would be pretty much parallel because we're so far away. Okay, now a ray is another definition that we should make, and a ray is basically a line drawn perpendicular to a series of wave fronts and it points in the direction of energy flow. Of the wave. So what we're talking about, if we go back to this picture, is the rays indicate which way the wave is traveling, and for light we're talking about the ray of light. So these are two very important terms, wave fronts and rays. Now something else that I want to point out is that our eyes can only tell us if a ray appears to come from somewhere. So in other words, and we'll come back to this, when you look in the mirror, that is what we call a virtual image. So you have this mirror and there's some object in front of it. Well, it looks like if a light ray hits that mirror and bounces off, it looks like it came from behind the mirror. And so the point is that our brain can't distinguish between real and virtual images. And we will talk a lot more about what this means. But in other words, your brain couldn't tell you, if we didn't know that this object was here, if we had our eye right here and we were, well, it looks kind of angry, but we were looking sort of this way, we wouldn't be able to tell if the object was really behind the mirror or if it was in front of the mirror. And so this is a way that sometimes our brain gets tricked. But more about that later. And finally, we come to our definition of geometric optics. Okay, so geometric optics is what we usually call the use of wavefronts and rays to describe reflection and refraction. Now there's another type of optics that we call physical optics, but we're not really going to be discussing that right now. We may come back to that a little bit later. So geometric optics is the use of wavefronts and rays. Okay, so that's it, and next time we'll be talking about reflection and how mirrors work in a little bit more detail.